everyone, I'm Jim from Team 67, and in this video we are going to demonstrate the Ansible script, like how to do the initial setup for the virtual machines. So at this stage we have already created 4 instances on MRC, and every instance had Docker installed it. Also the volume has been attached. Also, the requirement environment file for each application has been stored at the right directory. So as you can see, the script for YAML, we have CouchDB setup for each node. Then we will do the cluster setup. Then we will deploy Mastodon harvester, Twitter harvester, then the backend and front end. So before we start, I just want to make sure that there's no running a container on each virtual machine. So you can see there are no running container on any virtual machine. So let's go back to Mastodon harvester, which I can execute our initial setup script. Okay, so first of all, I'm going to check whether the CouchDB has been set up properly. So I'm going to use the command here, just checking the membership. So as you can see, there are 3 CouchDB nodes on 3 different virtual machines with 3 different IP address. So I think CouchDB cluster has been set up successfully. Then we want to check that Mastodon harvester is running on Mastodon harvester instance. So as you can see, there's a container is running right now, and this one is CouchDB. Then we can go to the Twitter harvester. So as you can see, there are another running CouchDB, and also this one is for the Twitter harvester. Let's go to the CouchDB master. So this is the master node of the CouchDB, and yeah, it is running as well. And let's move to the web server. So we can see there's a backend server running. It's named by the Flux Docker. Yeah, because we use Flux as our backend, and also the front end. So it's using React, and both of them are running. So yeah, that's all about the initial setup. And in the next session, we will talk about the monitoring. This is related to our scaling up and scaling down thing. Yeah, we will show the scalability in the next section. Hello guys, this is Jim from Team 67, and I'm going to continue to talk about our Ansible script. And in this section, I'm going to talk about scalability. So before we're doing that, I would like to talk about our system design, and especially for the backend. So initially, we will create a backend server in its instance 4. However, if there are too many clients visit our website and sending too many requests to our backend server, the backend server will have a counter and it will refresh every minute, and it also has a threshold. So if there are too many requests, it will just set the status to true. That means that we should create another server for the load balancing. So as you can see in instance 2, there is another Flux backend. Yeah, so it is like a backup server. So let's just back into our code. So, as you can see here, when we initiate the setup, we have also a start monitoring role. And if we go into the start monitoring role, we can see that the line 2 is a command actually. And what it does is it's copy the Chrome tab text replace the executed cron tab. So let's have a look in cron tab. So on line 25, it's basically mean we will run the monitoring scripts every minute. So let's go to monitoring script. You can see there's another playbook, and it's called monitoring YAML. And under that, we just echo the date. So we can make a log file. So we want to make sure that the cron tab is actually running. Okay, so in monitoring YAML, we can see another row just called fetch status. And if we go fetch status, we can see that the Ansible will send a request to the backend server, the original one, by this address and also the status, which it will get true or false. So if the status is true, it will just scaling up. That means that we need to deploy another backend server on Twitter Harvester, which is the instance 2. And if we get false, we just scaling down and we just remove the container. Okay, so let's see. Currently, you can see that the status is false, and we are going to make it become true now. So what we do is we just curl the data. So as you can see now, we can still receive the data. It's looking normal. However, if the request is over the threshold, we got no full result, and the forwarding become true. So it's basically telling the front end that we need to visit another backup server to fetch data because it won't do the work for you. Okay, so after we try this, it just become true again. Then let's see. As you can see here, line 15, the status turned out to be true. So it means the new container, the backup container, should be deployed on Twitter Harvester. Okay, so as you can see, this is a Flux Docker, which is our backend. And now we just need to wait for a minute. If we don't curl the data, and also there is no visitor going to visit, then it will become false. The status will become false after 1 minute. So yeah, just wait another minute. Okay, so as you can see, the status turned out to be false. So the demand is lower now. And we just need to wait it for remove the container. Let's go back to Twitter Harvester here. So now you can see there is no Flux Docker. That means the backup server has been removed. I'm Jing again, and I'm going to talk about the other scalability that's about our Mastodon Harvester. So far, of only Mastodon Harvester is deployed on instance 1. And if we would like to collect more data from different server, we can deploy another Mastodon Harvester on CouchDB instance, which is instance 3. And it can be done by the Ansible. So before we go into the script itself, I just want to show you the database right now. So as you can see, the Mastodon, there are two databases. One is Mastodon and one is Twitter. So this one, Mastodon, is from the original Mastodon Harvester. So we are going to create another database after we deploy backup Mastodon Harvester. So let's look for the thing. And this instance 3, and this is an environment file for the Mastodon setting. So the comments line are taken from the original Mastodon setting. However, since we don't want to duplicate data, so we need to change the URL. We need to fetch the data from different server. So we change from AU to word, and just need to be careful that the Mastodon access token need to be different as well. Also, we set up the database name to Mastodon word. Okay, let's go to CouchDB master. So I just want to make sure that there's no Mastodon Harvester running on CouchDB master. So as you can see, there's only CouchDB running. Then we go back to our script and execute the script. It's called backup Mastodon Harvester. So let's do the work. Okay, it has been set up. Let's go back to CouchDB master and check. Okay, yeah, it just has been set up 15 seconds ago. Then let's go to database, and we can probably can see a difference. It takes time to process because it needs time to build up and fetch the data. Maybe another 15 seconds. Okay, it show up. So as you can see, there's a new database called Mastodon Word has been created, and there are 2 documents in there. So that's mean our additional Mastodon harvester is created, deployed by Ansible script. So now I would like to try. I would like to remove the container by the Ansible as well. So let's see. We're just going to use the remove Mastodon harvester script, and let's see. Yeah, so let's check CouchDB master. So yeah, as you can see, the Mastodon harvester is no longer exists, which means the script is working. So that's all about Ansible. Thank you.
Mastodon data is growing, and also Twitter data is growing. As we do the bulk update, the Twitter data is updated by 10th, which is fast growing. We also upload MapReduce function in advance, so we can see the MapReduce function while we uploading as well. Great. The Mastodon, amazing, it works well. We have 2 databases, but we give them to freedom to choose database name, but we choose Twitter and Mastodon each of data name. For the database for Mastodon, we have a happiness design document. It has a view for score and behavior. For score all mean the happiness score in whole Australia. So if you run the code, you can see statistic of whole Australia of happiness score. It shows around 9.7. We also have a score, happiness score by day of week. 0 means Sunday, and 1 is Monday, so on and so on. If you reduce, we have 7 numbers. Each has a statistic of happiness score. Like a day of week, we also have a happiness score by hour and happiness score by month. We also have a behavior for happiness behavior for Australia. If we reduce, we can tell our achievement for our happiness behavior is the most. So which means people more talk about achievement when they're happy in the Mastodon. We also have a happiness behavior by day of week as well. An hour and months as well. For the tweet data, we have GCC, which is location data, and also SAL. So from score view, we also have score for whole Australia. So we can have total number of score, happiness score, and counts, and average of happiness score. We also have a happiness score by state, and each of Australian state represents to a number, and 1 is the New South Wales, and 2 is Victoria, so on and so on. We also have suburb and locality. Reduce. We also have a set of each of suburb and locality. Score by month and hour. We also have GCC. This figure shows the happiness score statistic by each of GCC. We also have 2 conditions combined. So we have happiness score by month and GCC. MapReduce. So this is mean Group67 on February, and this is Group67 on March. We also have hour by GCC, and also have behavior in happiness behavior in tweet. And also same as Mastodon, we do have a behavior by day of week as well.
Come to our project. Our project is called Happiness Mining because we want to tell a story about happiness on social media, Twitter and Mastodon. So as we scroll down, we can see the overview of our project. In total, we analyzed the happiness of around 1.8 million geolocated Twitter data and around 300,000 Mastodon data. We created 3 scenarios. The first one is happiness trend by time in Australia, and the second one is happiness trends by location across Australia. And the third one is the reasons for happiness. We created interesting questions to engage our audience, such as, does morning or night bring more joy? And is happiness found in the absence of marriage? And how does higher education influence average? Here is our footer. In the About page, we have an introduction of our team. We have James, Ben, John, and Matt, and me. To explain the algorithm we use to calculate happiness, we will explain that with an example. So studies has used crowdsourcing to establish a data set. In total, around 10,000 words were rated from the range of 1 to 9, where 1 word will be evaluated by 50 individuals for an average score. As we can see from the table, among all those words, laughter is rated as the top one with the highest average score of 8.5, and terrorist is the word with the lowest. To calculate the average of happiness score of a text, we would firstly map the happiness score to each word in that text, and then we will eliminate the neutral words, which are scored between 4.5 and 5.5. Then we will sum up the weighted score for each word in the text, and the happiness score of this example, I had a very nice branch, is calculated to be 6.3. Additionally, we want to figure out the reasons for happiness, so we created a classification model. This is based on an NLP study, which they classified happiness into 7 categories: achievement, affection, bonding, enjoyment, enjoy the moment, exercise, leisure, and nature. So this project is called HappyDB, and they crowdsourced around 100,000 happy moments and labeled them with the categories. For example, I finally mastered how to make a crispy tofu is classified as achievement. Then we will discuss our first scenario, which is happiness and time.
Hi, my name is Matt. So now I'm going to introduce you guys about scenario 1. Scenario 1 is about the happiness and time. We will mainly focus on 3 sub-scenarios in this part. First one is the happiness trend from 2022 February to 2022 August. And the second one is the happiness trend by hours. And the last one will be the happiness trend by day of the week. So for the first sub-scenario, as you can see here, the trend of the happiness score from March to July has increased. And we search about the news because the GDP was increased by 0.7%, and the economic is recovering from the COVID, and people have more money, and so they may feel more happier. And also the happiness score in March and June was lower than the other. As a student, in my point of view, and my assumption is March is the start of the semester, and the May is the due date of the most of our assignment, including this one. And after that, we move to the June, the happiness score increase again because we are having holiday. And on the July, the happiness score decrease again because we just get our result of the exam back. So that's quite makes sense to me though. So now we are going to move to the scenario 1.2. In this section, we will compare the Mastodon data and the Twitter data. And as you can see there, the top one is the Twitter data and the bottom one is the Mastodon data. There are different trends between Twitter and Mastodon, but there are something in the common. Most of people feel happier during the night time, and feel a bit suffering during the day, especially 8 o'clock to 10 o'clock, the time for getting up to the school and go to the work. Also, we observe that the average score of the Twitter is higher than the average score for the Mastodon data. People on Twitter express more happiness than people on the Mastodon. And the last one, we will move on to the happiness score by day of the week. Both trends are expected, like during the weekend, people will be happier and have time to share their happiness on the social media. However, the happiness score on Monday are above the average line for both Mastodon data and Twitter data. That's quite surprising. In my point of view, Monday is the start of the week, and people need to go to work and need to go to school, so the happiness score should be lower. There might be because people go back to the work and school can share their experience during the weekend with their friends and colleagues or classmates. So that's why the happiness score on Monday is also above the average line. And that's all for the scenario 1. And John will talk about the scenario 2.
In the scenario 2, we will talk about the tweet happiness score by locations. So what is happiness score in average score in Australia is 5.9, which shows Australian average happy tweet is happy, and this is state across happiness score across the state in Australia. It shows Western Australia is the least happy and Tasmania is highest happy. If you click that, you can see the happiness score for each state. Okay. For the GCC, we also calculate happiness score, and Northern Eastern part appear to happier than South and West part. A part of Great Darwin, for each state, the great capital city are happier than the rest of areas. You see, amazing. And if you see, the rural Victoria is lowest happy score, and the rural northern part is highest happy score, which indicates 6.02. Okay. This is Seoul, suburb and locality, and this is showing that happiness score by each Seoul. This is interesting. This is many of Seoul in northern part is lowest happiness score, but this GCC indicate highest. We figure out that what part of region is the population difference between GCC and Seoul. I will move to Ben.
Alright, so looking at scenario 3, we're looking at the influential factors and the correlation analysis between Twitter data and pseudo data. Our goals here are to look at the social and economic factors influencing our happiness score, and to look at the reasons for how our happiness is classified. So here you see our reasoning: achievement, affection, bonding, enjoying the moment, exercise, leisure, and nature. We can see that on our graph here, which is a log graph of our total tweets on the y-axis, and then on the x-axis we have the day of the week, and we can see that achievement appears to be our most significant factor here, with affection and enjoying the moment second and third. Our least significant factors are exercise and nature. And important takeaways are that the changing in the graph doesn't necessarily just indicate that people are going to be doing a specific thing more, but more that they're just tweeting more at that specific time. Say on a Thursday, when more people seem to be tweeting about nature here, but that's more just because more people are tweeting on a Thursday. Using that, we can understand that on Fridays, we can see a dip in people tweeting about exercise, and then it being more than expected on a Saturday. That would be because on Fridays, less people are going out and exercising, and on Saturdays, they're probably enjoying their time off and exercising more. Looking at our correlation heat map here, we see this first column here represents our happiness score, and these are the factors that it correlates with from our pseudo data. From this, we can look at the correlation with a larger number being that of more significance, with positive being a better correlation and negative being a worse correlation. And from this, we can see the social factors such as unmarried people, large households, and higher education having a positive correlation, with age having a negative correlation, interestingly. In terms of economic factors, we actually see that unemployment has a large positive correlation, which is interesting, and working, rent, and income variables seem to have negative correlations, which brings in an important discussion of unrepresented people within our data, that being that if unemployed people have more positive correlation, that's probably the unemployed people that actually have the means of tweeting, whereas a lot of unemployed people probably wouldn't, and that's why in this sort of our analysis, correlation does not necessarily equal causation.